Hey guys, even though I'm not there with you today, we are still going to get started and move on to our next chapter, which is matrices. What you're going to be responsible for today is just learning the basics of everything that there is to know about matrices, and I know you can do all this without me there. So what you have is a note guide that will go through this entire PowerPoint with you, and we're going to divide it up into sections. So we're doing there should be about 2 to 3 videos. You also need to make sure you have the agenda that the sub passed out and flip it over to the back where all of the matrices are listed, because you're going to need that for some of your examples. Okay? Now, let's get started. So, a matrix, okay, or plural matrices. What it is just an organized set of numbers. It's a whole bunch of numbers that are just organized into rows and columns. Okay? Often people describe it as an array of numbers. And all an array means is that it's set up into an organized fashion, which is usually the rows and the columns. So, before we get into the actual details of everything, one thing you need to make sure you know is that matrices are always named with capital letters. So, for example, capital letter A would be talking about matrix A. So always make sure your matrices are labeled with capital letters. Now, what's inside the matrix? Matrices can be as big or as small as you want them to be. And each number in there is what we call an element. And every element can be traced back to its rows and columns. Okay? Remember, your rows are the horizontal lines of numbers. Okay? And your columns will be your vertical lines of numbers. All right? If you ever get confused what's a row and what's a column, think about a house. Okay, if there's columns in front of a house, they always go from top to bottom, right? From the roof to the ground. So columns go vertically, which means the rows have to go horizontal. Now, going back to the elements, notice how each thing in this matrix is labeled with a little a. Well, when you are talking about an element, if the element's inside big A, then they are going to all be little a. If this matrix was big B, all of these letters would be little b's. Then the number that's next to in the little subscript, each of the lowercase letters, tells you what row and what column your matrix element is in. So for example, A11, that means you're in the first row and first column inside matrix A. So A12 would mean matrix A, first row, second column. If we skipped down here to A23, that'd be matrix A, second row, third column. A34, matrix A, third row, fourth column. Notice how I'm always saying rows, then columns. And that's a general rule of thumb with matrices. No matter what you're doing, you always go rows, then columns. That includes when you're talking about the dimensions of your matrix. A matrix of m rows and n columns is called a matrix with dimensions m by n. That's row by column. There's tons of ways of trying to remember this, but my favorite, since I'm born and raised in Georgia, Southern girl at heart, is that I always remember RC Cola and a moon pie. RC Cola means your rows and columns, and then we throw that moon pie on the end because that's just a Southern combination. You have your RC Cola and your moon pie. If you're ever in Chattanooga, Tennessee, you'll see moon pies all over the place because that's where they originated. And they're often sold right next to a case of RC Cola. So, little Southern history for you as well. So let's look at actually finding some dimensions. Let's look at this first one, okay? Notice there's 2 rows, and there's 1, 2, 3 columns. So the dimensions would be a 2 by 3. Let's look at our next one. Here you have 3 rows and 3 columns. So that would be 3 by 3. Down here in number 3, we have 2 rows, but it's only 1 column. So the dimensions would be a 2 by 1. And then in number 4, you have 1 row and 2 columns. So that would be a 1 by 2. Now, I'm going to give you just a few seconds. I want you to look at the next slide on your notes and fill in the dimensions. Okay? We'll go over the answers in just a second. Just remember, it's always your number of rows, then your number of columns. So just take a couple seconds to figure those out. Okay, let's look at number 1. There's 3 rows and 2 columns, so it's a 3 by 2. Number 2, there's 2 rows and 2 columns, so it's a 2 by 2. Number 3, you've got 3 rows and 3 columns, which would make it a 3 by 3. Number 4, it's only 1 row, but there's 2 elements in it, so that makes it a 1 by 2. Number 5, there's 2 rows, but there's only 1 column, so that's a 2 by 1. And then look at number 6. It's just 1 element inside the whole matrix. Well, 1 element gives you 1 row and 1 column. So that would be a 1 by 1. Now, a little vocab for you. Any matrix that has the same number of rows as columns, they're called a square matrix. So for example, a 2 by 2, a 3 by 3, and a 1 by 1, those are all considered square matrices because their rows and their columns are the same length. So now let's look at the address. Okay? So like we mentioned at the very beginning, every matrix has elements in it, and every element has a specific address. Okay? Remember, the little letter tells you what matrix you're in, the first number is your row, and the second number is your column. So using this matrix A, if I asked you for little a 2, 1, I'm asking you to look in matrix A at the second row, first column. What number is there? Well, second row, first column is a 4. So your answer would be a 4. Now, look at the back of that agenda. Okay? Let's find B34. That's telling us little b means matrix B. We're going to the third row and the fourth column. What number is there? Hopefully you all see a -7. What about B42? Fourth row, second column of matrix B. Did you get -5? How about B54? Matrix B, fifth row, fourth column. That should be a 3. How about E32? Notice we've switched letters. We're now on little e, so we've got to go to matrix E. That's the third row and the second column in matrix E, which should be a -2. How about G21? Matrix G, row 2, first column. See a -3? Look at D21. Is something funny going on here? That's matrix D, second row, first column. Yeah, you should be a little puzzled because there is no second row, first column. So there's no element there. And when there's no element that matches the address I'm asking for, it's simple. That element does not exist. So that's your answer. Okay? Now, just like with everything else we've done this year, if you can go one direction, you can go the other direction. So if I can give you the address and you tell me the element, I should be able to give you the element and you tell me the address. So if I said find number 7 in matrix X, well, we go to matrix X on that back of the agenda. Where's the 7? That should be the second row, first column. So your answer would be a little x with a little 2, 1 in subscript. How about 0 in U? That would be first row, first column. So it's going to be a little u with a 1, 1 in subscript. And last but not least, how about -5 in P? Did you find it? Should be first row, second column. So it's a little p with a 1, 2 next to it. Not too bad, right? Pretty easy? Common sense? All you have to remember is your RC Cola and your moon pie. Rows, then columns, and all of this is a piece of cake. Okay? So that ends this first section. Go ahead and turn your notes to the next page. Keep that agenda out for matrices. And when you're ready, click start on your next video. And we're going to move on to addition and subtraction.